we're starting with chapter 5 in the textbook, which is on sets and counting. So basically we're gonna have to start with a bunch of definitions to really get ourselves on the same page, and then we can start really doing some stuff. So first of all, a set. Well, a set is just a collection of objects, okay? So for example, so the objects, they can be anything. So for example, if I take 1, 2, 4, so the way you denote a set is by putting these kind of curly brackets, and then the things that you write inside the brackets are the objects within that set. Okay, so this is a set which has 3 different things in it: the number 1, the number 2, and the number 4. So I've said that it's a collection of objects. These objects have a sort of a special name. So the objects in a set are called the elements of the set. So for example, 1 is an element of the set 1, 3, but 2 is not an element of that same set, 1, 3, 9, 12. Now, a few different things I want to point out about about sets. Order, like the order, so I've listed these elements. I keep listing them in like increasing order, but you don't have to. Order doesn't matter in a set. So if I take the set, A, B, C, it is the same as like C, A, B. So if you just mix the elements around, it doesn't change the set. So all we care about in a set is which elements it has, not what order they come in. Another thing to note is that duplication doesn't count. What I mean by that is that if you have a set which contains an element twice, you don't really count it twice. It just kind of counts once. So what I mean is, like, if I take 1, 1, 3 is the same as just 1 and 3, because if you list something twice, it only really counts once. So it doesn't, and so it's also the same as 1, 1, 3, 1, 3, 1. These are all the same. Any questions about any of that so far? I guess one thing that kind of came up here is to note is that the elements of a set, they don't have to be numbers. Okay, I know we're in a math class, but not everything has to be in numbers. So for example, I could take the set A, dog, at symbol, happy face, and that's a set. Or I could take the set, so kind of informally, we can also kind of represent, so in all the examples we've seen so far, I've listed all the elements. You can also, that's not practical. Suppose a set has 1,000 elements, it's not necessarily practical to list them all, right? So sometimes you want to kind of, informally have a shorthand for writing a set. So for example, I could say the set of all UVic students. Or I could write like this, a set 1, 2, 3, ... 100. And hopefully it's clear what these mean, right? So this would just mean it's the set where the elements of that set consist, like each student is an element of the set. So I guess presumably all of you are elements of this set, right? And then I think it's clear enough that we're listing all the numbers 1 up to 100. We just don't want to list them all. Yeah. There is no difference. There wasn't really a good reason for this, except for the fact that at this point I hadn't said like what an element means or anything. I don't know. But yeah. So Yeah, there's really no difference between what I'm saying, where I'm using the word objects or elements here. But technically, like, we should use the word elements. Any other questions at this point? Oh, yeah. You can write equal signs. Yeah, yeah. So you can write, so when I wrote is the same as, you can also write, let's say 131 equals 1, 3, yeah, which is equal to 3, 1. Of course, you should only write this if it's true. So a bit more notation. So the symbol, so this kind of thing that looks like a, kind of like an E. So this means, so basically this is just a shorthand for like a string of words, meaning, you know, is an element of, right? So if I write, yeah, 3 is an element of the set of all odd numbers, for example. 4 is an element of the numbers 1 up to 1,000. But you could also do something like, you know, 4 is, so if I write this element of symbol with a cross through it, which is, I guess you're probably used to like not equals symbol, right? So this is kind of the same thing. If you cross any mathematical symbol out, it just means not. So 4 is not an element of the set of prime numbers. So yeah, so this translates to is an element of, is an element of, is not an element of. Yep. It has to be not part of the set at all. Yeah, yeah. So yeah, this indicates like a relationship between like an element or a potential, like an element and a set. So it's like when you write this, it means like this is a sentence, right? 4 is an element of this set. Yep. As a, sorry? Like, oh, do you mean like, can you just write this as this? Or you should probably try to, yeah, follow the notation. It could get confusing for a marker or something. So you should try to really, yeah, practice making this symbol. Yeah. Yeah. Oh, sorry? It's more of just stating a fact. In theory, you might be able to use it that way. So if you want to do 1 to 100 excluding 4, there's other notation for that. Yeah, we'll talk about that. Any other questions? This is great so far. Lots of questions. Keep them coming. Don't be shy. Okay, so basically, I'm just going to keep giving you more notation for a while. So, so if we let A and B be sets, so the union of A and B is the set containing all elements of A or B. Okay, and the notation is A with like something that looks like a U, but without there's no like tail, A union. So this means A union B. So as an example, if we let A be the set 1, 2, 4, and B be the set, for example, 7, 3. So the union, you should think of union like, I mean, the word union kind of means putting things together, right? So when you take the union of two sets, you kind of merge them together. So it's the set that contains all the things that are in here or in here. So 1, 2, 3, 4. And as I said, it doesn't matter what order I write these things in, but the point is the number 1 is here, so it should be in the union. 2, 4 is here, 3 and 7, and you don't add any other stuff, just that. Yep. You're okay? Okay. Yeah. Oh, all of the elements of both of the sets. Yeah. Maybe the way I've stated this isn't that clear. What I mean is it has every object which is either in A or in B goes into the union. Yeah, that's a good point. Actually, I was just thinking I should probably mention that. So exactly as you said, so let's say I just throw the number 2 into here. Well, that won't change the union because, well, the union is everything that's in either in here or in here, the fact that 2 is in both of them doesn't really make a difference, right? I mean, I could have listed 2 twice if I wanted to, but as we remember, duplication doesn't count for anything, so it still have the same union. Yeah. You can, yeah. It'd be a little bit cumbersome to write. I mean, to be honest, if you were dealing with that, I would probably just I would just keep it written as the union. So I'd say, 1, 2, 4, union, odd numbers. I wouldn't really have a better way to then express it. I mean, this is a valid set as it is, even though it's not sort of simplified in any way. It's still valid. Yeah. It's exactly this set. No. So yeah. So it contains the elements of A that are in A or in B, and only those elements, nothing else. Yeah. I mean, probably maybe it's just called a bracket or a brace. Yeah. Any set can be combined with any other set. Yeah. The union it's always valid. Other questions? Okay, so a closely related concept is intersection. So the intersection of A and B is the set of elements that are in both A and B. Yep. Yeah. In fact, if some of you are, I don't know, have any sort of computer science background or something, you might have seen operators like or and, which have sort of or sort of has the same symbol. I mean, same general shape as this. This is not really part of the course. And for the intersection, the notation is similar to the and. So this is like or. So maybe let's do the same example. So A is 1, 2, 4. B is 7, 3, 2. So can anyone tell me what the intersection is? Yeah? Yeah. So if I'm being really pedantic, I'll say that it's the set containing the number 2, but it only contains. By the way, that is maybe something to keep in mind, that you may lose marks, like if you were writing and you wrote that, because A intersect B is not equal to a number. A intersect B is equal to a set that has a number as an element. And it might seem a bit pedantic, but so yeah. Exactly, yeah, exactly. Here's another example. So what if I let A, actually let's go back to our original choice of A and B from over there. So if we let A be 1, 2, and 4, and B be 7 and 3, now if I look at A intersect B, there's nothing in it, right? Yeah, that's right, exactly, yeah. So, I mean, you could write this maybe like this, braces with nothing in it. But there's actually a better way of writing this. This is kind of the standard terminology or standard notation, is to write kind of like a 0 with a cross through it. Yeah. In some sense, yeah. In some sense, it cancels out. Well, no, sorry, it doesn't. No, it doesn't cancel out. It's not like an exclusive or. So if I say, yeah, if you have an or between two things, if one of them's true, it's true. If the other one's true, or if both of them is true. So yeah, no, there's no cancellation. Right. So this symbol means the empty set. So it's a set with nothing in it. Yep. So in this case, there's no need for the bracket. So when you write this symbol, it means the same as this. So if you write this is not the empty set. This would be a set containing the empty set as an element. So this is not the same as. So if you're talking about a set with nothing in it, that's the. It also doesn't mean 0. It means. Okay, so often when we're dealing with sets, we're often working in some sort of like we often think of things as belonging to a sort of universe in some sense. So when I'm writing these sets containing numbers, you might kind of implicitly in your mind think, oh, these sets come from, the elements come from the set of all numbers or the set of all integers. So the universe that the elements of a set, so that the elements of a set come from is denoted. The reason for doing this probably isn't obvious right now, but let me give you another definition which explains why we sometimes need to specify a universe. The complement of a set A from a universe U is the set of all elements of A that are not, or sorry, of U that are not in. And the notation for this, for the complement, is A prime. So maybe I'll do an example. So this is the type of question, like a type of question you might see. So let the universe be, so U equal to the numbers, let's say 1 up to 10, and A be the set of the numbers 1 up to 5. And you could be asked, what is A prime? Yep. Oh, sorry? Yep, exactly. So, but specifically when you say anything, it's got to be anything in this universe that's not in the set. Exactly, yep. So the answer would be A prime is equal to the numbers 6, 7, ... up to 2. Yeah, because it's everything that's in the universe that's not in the set. But you can see it's kind of important that I specify the universe, because if I change the universe, it'll change the complement, right? If this universe contained the numbers 1 up to 100, then A complement would be the numbers 6 up to 100, right? So that's why you need to specify a sort of. Any questions about that? Yeah. Yeah, so complement means the things that are not in the set. So the things in the universe. So yeah, this is defining the word complement. So the complement of A is all the elements of the universe that are not in A. And the notation is this like A prime thing. So this would be the complement of 1 up to 5. Okay, so a bit more, even more definitions. So two sets, A and B, are said to be disjoint if A intersect B is the empty set. So the main reason I bring this up is because this word might get tossed around in homework and in the textbook. So this just means, so two sets are disjoint if they just have nothing in common, right? They don't share any elements. Another bit of terminology, apologies that this is all kind of boring, but a subset of a set A is a set, or sorry, maybe I'll say this in a way. So let A and B be sets. So basically subset means, if you imagine a set as being like a box containing a bunch of elements, like a subset is a set whose elements are in that original set and contain anything outside of it. So B is a subset of A if every element of B is an element. So here the notation, so if I write this symbol, it means is a subset. So for example, 1, 2, 4, I don't know why I keep picking this. So this is a subset of 1, 2, 3, 4, 5. And the way you check that is you check that every element here appears in this list. Nope, because, yeah, so this subset thing is generally, it's not symmetric, because, so So here you can see everything you see here also appears here. Yeah, yeah. This would be your B, and this would be your. So yeah. So for example, 1, 2 is not a subset of the set containing just 2. So maybe I should yeah. Actually A is always a subset of itself. I just wanted to do a couple of quick examples to kind of consolidate. Let S and T be sets. I've written some stuff here, so basically what I would like to know is, so if I write S union, which of these 3 definitions corresponds to S union D? So the first one is the set of all X in the universe, such that X is not in S. Second one, the set of all X, such that X is in S or X is in T. And the third one is the same thing, except X is in S and X is in T. Yeah, exactly, yeah. Right, so that's what, this is maybe a better way of defining it. Before I did it completely in words, but using this notation, this might be a bit better. So it's all the things that are in S or T or both, it doesn't, yeah, at least one of them. What if I wrote S prime? Yeah. Yep, exactly. Actually, does anyone remember the technical term for this S prime thing? Yeah, exactly. So this is the complement. So, and maybe I'll remind you that this is the union of S and T. Okay, and then the last one, I guess we can, by process of elimination, we can probably guess that this is C, right? So it's all the things that are in S and in T. Okay, and this is the intersection of S and T, or S intersect T. Let's do another quick example. So let's say our universe is a collection of students who are taking, or let's just say it's all the people in the world. And let's say S is the set of all Spanish speakers, so people who can speak Spanish. T is the set of Turkish speakers. And suppose I ask you to describe the set S intersect T prime in words. Yeah, exactly. So in case you didn't hear that, so the description was, so it's a set of all people who speak Spanish and do not speak Turkish, right? And you can kind of work that, you can reason that out by remembering the definition of, complement and the definition of intersection, right? So everyone in this set should be in S and in T complement. Being in S means that you speak Spanish. Being in T complement means you do not speak Turkish. So yeah, it's all the people who speak Spanish and don't speak Turkish. Okay, so let's now move on to the next section. Are there any questions about that? Yeah. Yeah, so if I was asking you to describe S union T, it would be like, yeah, speak Spanish or Turkish. Yeah, so like they speak at least one of those languages. People who speak both would also be in the set. Exactly. Any other questions? This is, by the way, a really typical type of question you'll see in practice questions and on tests and quizzes and